In this video, we want to see whether the following series converges or diverges. So I'm going to show two different ways to prove this. The first way is by using a direct comparison test. So we want to compare this to something that we know converges or diverges. So let's focus on the square root here. So basically, this is 1 over the square root of n. Obviously, it's not exactly, but it kind of looks like 1 over square root of n. We know that this is going to diverge by the p-test, so we want to find something smaller that diverges. If something smaller diverges, then something bigger will also diverge. Now, what is something that's smaller? Well, we need to make the denominator bigger. So the question is, what's bigger, the square root of n or the square root of n plus 1? The answer is the square root of n plus 1. So I'm going to change the square root of n here into square root of n plus 1. So we have 2 copies of that plus 3 copies here. That's going to be 5 square roots of n plus 1. And I want to find something even smaller than that. Okay, so how do I make something even smaller? I'm going to make the denominator bigger. So instead of n plus 1, I'm going to put n plus n. So n plus n is just 2n, which I can factor out the square root and have 1 over 5 times square root of 2 times square root of n. The reason I did all of this is to get it basically the form 1 over square root of n. The constant here doesn't really matter. So I know that with 1 over 5 times square root of 2 times 1 over square root of n, that's going to diverge by the p-test. So by the direct comparison test, our original series also diverges. So if something smaller diverges, then something bigger will diverge. Okay, now let's use a limit comparison test. So we want to compare it to a limit, or to another sequence rather. So let's just compare it to 1 over square root of n. So we're going to take the original sequence divided by 1 over square root of n. And so this is basically the same thing as multiplying, because we're dividing by 1 over square root of n. The same thing as multiplying by square root of n. So that's why the square root of n is at the top. And so now I just need to find the limit of this. Well, I can divide everything by the square root of n, or the square root of n plus 1. Here, it doesn't really matter. I just chose to divide by square root of n because there's 2 copies of square root of n's versus 1 copy of the square root of n plus 1. And so the top becomes 1, and then it's all over 2 plus 3 square root of n plus 1 over square root of n. I can bring both of these inside of 1 square root. So basically you factor out the square root. You're left with n plus 1 over n, which you can break this up into 2 separate terms. You have n over n, which is 1, and then plus 1 over n. 1 over n is going to go to 0, so we have 1 over 2 plus 3, which is 1/5. So because the limit is finite and positive, here being 1/5, and the sum of 1 over square root of n diverges, then by the limit comparison test, our original series also diverges.